Hey guys, how's it going? So we're continuing into our paper. So we have a question here, psychogeometry. Okay, so question 8. This is A, B, C, and D. I told you that these details usually are the same details that you have here. And almost always when we refer to this, it will be, we won't have understood the diagram here. But let's just read, just in case. Okay, so A, B, and C are points on the circumference. So the center is O, okay, which is good. So O is the midpoint for BC. Okay, so is the midpoint for BC, that means that is the center. And ABC is equal to C 38. So this is angle here that we're given. The tangents are drawn from T, okay, from this point, and they touch the circle at point A and B like this. Okay. So I asked to calculate BCA. So BCA with this angle here. Okay. So one of the first things that you notice is we're given the diameter. Every angle that's subtended at the circumference by the diameter, it's always 90 degrees. Okay, so if it's always 90 degrees, that means that this angle here, you can actually identify it. To show that you know how to identify angles, you can say BCA, okay, is equal to, it will be 90 minus, then you say ABC, okay, this angle ABC. So it'd be 90 minus 38. So 90 minus 38, you get what? You get, is it 52? You get 52 degrees, yeah. Like this. So you get 52 degrees like this. And in the B part, you're asked to calculate ATB. So ATB, which is this one here. Okay. So, so one way to go about it is to recognize that this one, it's coming from the center, and this one is a tangent. So this one must be 90 degrees. Okay. So if it's 90 degrees, that means that this one here is equal to this one. So there's actually a theorem that says this, okay? So that says that the exterior angle formed at the tangent, it's equal to the opposite interior angle of the cyclic quadrilateral, cyclic triangle here. So this triangle here, it's touching this part, this part, this part. So this part must be equal to this part. If you don't want to see it that way, you can just say it as this is 90 degrees, and if it's 90 degrees, here we have 38, so this one must be 90 minus 38. But then you could just as well say this one is just 52 degrees like this, okay? So this one should be an isosceles triangle. Always, the triangle formed at the tangents, they are always, this triangle is always an isosceles triangle. So this one must also be 52. Okay, so ATB is equal to ATB here, it's equal to 180 minus, you can say TAB minus ABT. Okay, so it'd be 180 minus 52 minus 52 here, so it'd be 180 minus 104 here, so 180 minus 100, you get 80, 80 minus 4, then you get 76. So this one must be 76 degrees, okay? So let me see if I can actually explain to you a bit more why that angle there is the way it is, okay? So whenever you have a triangle, so a triangle, let me just, so whenever you have a triangle having its limbs, so the legs, the vertices of the triangle, they are all touching on the circumference of this one, okay, so they are all touching on the circumference. Whenever you have such an occurrence, what it means is that this angle here, theta, which is formed at this, must be equal to this angle here. Okay, this is true regardless of if this is the diameter or not. Okay, so it actually works even if it's not the diameter. this angle and this angle, they're always equal. So how do you identify this angle? I always say go. So this one, it's like this, okay? So go inside, okay? So inside, and then you go at the top. That's one way to go about it, okay? So, but then the way that we actually did it was to say this one is 90 degrees. So 90 from 38, then you get this angle. This angle must be equal to this angle, and then we calculate the difference so that we could get this angle, okay? So inequalities, you're asked to find the integers that satisfy this inequality. So inequalities, they can be, this is a combination of two inequalities, okay, where the central term here, it's common between this and this, okay? So you can actually first you can have this inequality stopping it here, okay? So you can have 1 less than 3x plus 5, okay? So you can have that inequality there, or you can have the inequality starting from here. So you can have 3x plus 5 less than or equal to 11, like this, okay? So you can actually solve them the way that they are. And I advise you to, if you want, you can just solve them without shifting the x. There's a reason for this, okay? But here you essentially get 3x. This one you can push it to this part, okay? So you get 1 minus 5, then you get negative 4 here, less than 3x, then you divide both sides by 3, then you get negative 4 over 3 here. If you want, just for the sake of clarity, you can actually say negative 1 in the third, so that you know what's included and what's not included. You'll see it very soon when we are comparing, trying to find the integers, okay? So here you can say 3x, then you push this one to the side, then you get negative 5, then negative 6, 11 minus 5, you get 6, then you get 3x here, and then you divide both sides by 3, then you get x less than or equal to 2 here. So when you combine them, you actually have x at the center anyway. You're just combining them like this, okay? So the inequalities, you're not changing anything there. So 1 and a quarter, and this one is 2. So when you want to write the integers, you say x equal to, then you write like this, okay? So here, negative 1 and 1 quarter. This one is actually less than negative 1, okay? So that means that negative 1 is actually included, okay? So negative 1 is included. So 0 is actually an integer, and we include 0, then we include 1, and then here it's not a strict sign, so that means 2 is also included. So you'd have 2. Then yeah, this is essentially how you'd go about doing this, and we've done it. So yeah, this is cool. We skipped question 10 because there was something with scale drawing, so we skipped that part there. And what we do instead is to go to question 11, okay? So we skip to question 11, and here it's about matrices, okay? So we want to get the value of A and B. There's a chance that this will be a simultaneous equation. So here we are multiplying matrices. So matrices, it's row by column. So for the first row, for the first entry rather, you can have 2, then negative 4 here, so 2 by negative 4 plus 3a. Okay, so this row by this column here, that's what we did. So this row by this column, it actually represents this entry here. Okay, so it's equal to 7. So it looks like we won't be having any simultaneous equations. Okay, so this one is negative 8 plus 3a equal to 7. Then 3a equal to 7 plus 8. Then this is 15. This is 3a. Divide both sides by 3. Then you get 5. Done. Okay. So how do we get b? So b, we can use the bottom one here. So bottom one times this. Okay. So this one times this, we're supposed to get this. Okay. So this is a very tricky way of doing, because you're inspecting. If this really confuses you, then you actually have to work out the whole thing. It's still fine. And then you can compare with whatever parts you want. But then if you're quick on your feet, then this one multiplied by this one, you should be able to get this one. This one multiplied by this one, you should be able to get this one. Okay, so this one multiplied by this one, that's what we're going to do. So negative 3 by b, which is this row by this column, this and this, plus this and this. So plus 1 by 2 must be equal to 2. Okay, this part here. So negative 3b plus 2 equal to 2, like this. So 3b equal to 2 minus 2, which is equal to 0. Then b equal to 0, like this. Okay, so that's it. That's all there is to it. If you didn't understand it very well, then you actually have to do the whole thing. Let me see if I can do the whole thing. So the whole thing would be saying 2 multiplied by negative 4, then you say plus 3a on this part. Then you have to say 2 multiplied by b plus 2a, you say this part. Then you say negative 3 multiplied by negative 4 row column, okay, plus 1 multiplied by 3, this part. Then you say negative 3 multiplied by b plus 1 multiplied by 2, get this part. So you'll be having this equal to this, okay. So this one is slower than the method of inspection, but then at this point you can actually notice that we can get a from these entries here, and you can also get b from these entries here. Okay, so it'd still be fine. You would still be able to derive the very same equations that we had when you used that method there. So yeah, that's it.